Hi, everybody. This is Mr. Folly, and welcome to our second podcast where we will do a little bit of periodic table thinking. And let's hop to it. We're actually starting with electron configurations. So we're going to do each of these long electron configurations, determine the charges of ions given atoms, ion electron configurations, orbital diagrams, counting unpaired electrons, ions of the D block, and valence electrons. All that. Oh my goodness, you have a busy, busy night. So hopefully this will fly quick for you. So electrons in the periodic table. Electrons are in clouds called subshells that are seen by the blocks of the periodic table. Identify the S, P, D, and F blocks. So here's S, and the S block are these two parts right here, and a little helium. Okay. The P block is right here. Okay. The D block, which is middle part right here. So you got to be able to identify them all. And then we'll go pretty pink. F block is on the bottom. Okay. So you need to be able to identify the S, P, D, and F blocks. Okay, and the elements that go in it. So what subshell or block is K in? Well, K is right here. So that means it's in the S block. Technetium is right here. So it's in the D block. Iodine is right here in the green, which is the P block. Electrons are in energy levels that are represented by the period, which is the row on the periodic table. Electrons are in energy levels, which are represented by the row. So if I put those here, I'm going to erase my P now. It would be 1, 2, 3, 4, 5, 6, 7. By the way, these guys right here are in 4 and 5. I know that's weird, but that's where they are. Okay. What energy level is SR in? SR is right here. The energy level is 1, 2, 3, 4, 5. It's in the fifth one. And aluminum is right here, which is in the 1, 2, 3. Okay, so D exceptions. The D block is actually being added inside of the S. This means the D block will be off by 1 as far as energy levels. 4 energy levels. Okay. So what energy level are the D electrons in? In iron. Iron is right here. Oh, you know, if you're erasing more than I want, that's okay. Iron is right here. So it would be in the 1, 2, 3, 4. But because the D block is off by 1, it's 3D. Okay. The D block is being added inside. It's off by 1. So D is 1 less than expected. And Mercury is really in the 6th energy level, but that's 5D. The F exceptions. The F block starts with 58, and I actually put those in there up here where I said this is 4, this is 5. So it's easier just to remember that. So the F block starts with 58, follows 57. The F block is inside the S and the D. The F block is off its row by 2. What energy level are the F electrons in? So we got to find europium. Bad energy. Or bad I. Europium. And my other one is berkelium right here. Europium is in 4, berkelium is in 5. That's not bad. Representation. So if I have 3s2, okay, this 3 means the 3rd energy level. The S means the S block. And the 2 tells you how many 2 electrons in that 3s. So when I look at that, look at this periodic table again, I'm going to erase all this stuff so we can see it a little better. And we're looking at 3s2. Let's zoom. So I'm looking at 3s2. 1, 2, 3. That's the third energy level. Okay. S block. These are the S block, right? So third energy level. So right now I know it's one of these two. And because it's 2, it's the second one in there, and that's why it's magnesium. Okay. 5d5. 5d5. So remember, if I have 5d5, this 5d is really on the 6th level. So there's 3, there's 4, there's 5, there's 6. I'm in the D block right here. And I want to be the 5th one in there. Okay. So I've got lanthanum actually belongs here. And the one that I gave you, it shows up there, and it should be there. So I've got 1, 2, 3, 4, 5. Rhenium. Oh, did I do it wrong? 6th energy level, 5th element. Did I not count it right? 5th element, the D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's right. So 6th level. 1. Oh, if it's 5D. No. Oh, no, that's right. My little answer key is wrong. It is rhenium. Shame on me. Shame on me. Shame on me. Rhenium. Okay, so electron configurations follow the periodic table. Okay. This is really on page 2. So we're going to start with hydrogen. So hydrogen is right here. It's the first energy level. It's in the S block. There's 1 electron. That's it. First energy level, S block, the first one, finished. F. I'm going to start here. In my first energy level, in the S block, I filled it with 2. 1, 2. I'm going to F. I'm now in my second energy level. S block again, I filled it with 2. Fluorine. 1, 2, 3, 4, 5. So I know it's going to end in 5. Second energy level, P block, 5. That's fluorine. Okay. Bromine's going to end up all the way down here, right? But remember, they're going to start the same. So erase. Starting at the top. So it's going to be really familiar. This is for bromine. 1, S2. Next 2. Second energy level, S block, 2. So here to here. Still on the second row. Right, second row. P block. This is my P block. P. And then there were 6 of them. 1, 2, 3, 4, 5, 6. I'm going to bromine. I'm now on my third energy level. S block, 2. Third energy level still. Right? Now I'm in the P block. Third energy level. P block. 1, 2, 3, 4, 5, 6. I want to remind you, we colored in that S and P before, so make sure you have that handy. I'm still trying to get to bromine. Come on, bromine. Fourth energy level. S block. 2. These 2, right? Now I'm at the D. Now remember how the D block is dumb? So it goes down 1. So instead of being 4D, it's 3D. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. 3D10. And I have this part left over. Da-na-na-na-na. Back to 4. P. 1, 2, 3, 4, 5. 4P5. Noble gas, core notation. Start with the preceding previous noble gas in brackets, and restart the electron configuration from there. This will show the valence electrons, which are the outer S and P. D's and F's can be there too, but they aren't valence. All right, barium. I see you, barium, right here. So the preceding noble gas is this column right here. Okay? So the preceding noble gas for barium is xenon. So I put xenon in brackets. Okay. And then after xenon, all I have are numbers 55 and 56, which are these right here. 1, 2, 3, 4, 5, 6. Sixth energy level, S block 2. That's it. Lead, way down here, number 82. Preceding noble gas, still xenon. Now, what's mean about this one is I've got to get in the middle of this. So xenon, and I've got to get to lead. I've got these two, which would be, we just saw it, 6s2. I've got to go all the way over here, which is 5d10. But notice I have my little detour over here, right? I've got all of these. 4f14. Okay. See F block, and there's 14 of them. And then I'm finally back in here. This jumps back up to 6p2. All right. Ion determination. The periodic table indicates the charges of atoms when they form ions. Positive ions lose electrons, and if it's +2, they lose 2. Negative ions gain electrons. -3 means they gain 3. Here are your charges. Every periodic table you get, you should write this on. +1, +2, +3, 0, -3, -2, -1, 0. That's it. That's the list. So what's the charge on chlorine? Hey, it's -1. What's the charge on indium? Hey, it's +3. What's the charge on beryllium? +2. What's the charge on cesium? +1. Isn't that nice? I think it's better than nice. I think it's wonderful. Electron configurations of ions. Determine the number of electrons, add or subtract your electrons. And then note these will be isoelectronic with noble gases. They're going to be just like a noble gas. So if I have calcium +2, if calcium has 40, no it doesn't. If calcium has 20, it helps if I look at the right one, that's cesium. If calcium has 20, it will have the same as 18 argon. All right? So that means I'm just going to run argon's electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. I think that's argon. It is. So again, 1s2, 1s2 in blue, 2s2, second row, 2p6, 3s2, 3p6. There it is, and that's the right number. Okay. N-3, I'm going to add 3 electrons to nitrogen. So nitrogen is right here. 1, 2, 3. It's the same as neon. Well, neon is 1s2, 2s2, 2p6 to be the same as neon. Okay. Part 4, orbital diagrams. An orbital is shown as a box that holds at most 2 electrons. Equal energy orbitals like p's, d's, or f's add 1 electron to every box before any of them gets 2 electrons. So here's oxygen. So if I were to do oxygen's electron configuration, and this is going to be super fast for me doing it, 1s2, 2s2, where'd my s go? And then oxygen is 2p4. So if it's 2, fill them up. If it's 2, fill them up. 2p4. 1, 2, 3. So that's the part right here where add 1 electron to every box before any of them gets 2. There you go. So note this has 2 single electrons. Titanium. Titanium ends in it's 1s2, 2s2, 2p6, 3s2, s2. Oh man, I can't even erase today. 3s2, 3p6, 4s2, 3d2. Get rid of that little oogle word right here. So it's going to be fill them up until I get to 3d. 1, 2, 3, 4. Everybody gets 1, then you can get 2. 3s2. Everybody gets 1, then you can get 2. 3p. I'm missing 4s. There should be a box for 4s. And then 3d is 2, up, up. Also 2 single electrons. Lithium has 3 electrons. It's 1s2, 2s1, 1s2, up, down, 2s1, up, 1. All right. Orbital diagrams help show what it takes to fill an energy level and determine the charge. O is -2, so let's take a look at -2. O is -2 because it wants to fill the shell. So I could fill the shell by putting these 2 in there. See that? That'll fill it. Being full is stable. Okay. Oxygen is -2 because it takes 2 electrons to fill that shell. Titanium is +2 to empty the 4th shell. Okay, so here's titanium. So if I get rid of these, I'm sorry, the first ones you lose your outer ones. Sorry. Come on, go away, eraser. First thing I do is get rid of these, right? Or get +4, well, I'll get rid of those, and then I'll get rid of these also. Okay, so lithium is +1, because if it loses this guy right here, it will be a full 1s. Remember, the outer s and p are the only valence electrons that affect charge. Oxygen has 6, titanium has 2, the 2 that it has are the 4s, or the 2, and lithium has 1. Valence electrons, the electrons that react in chemistry, so we'll focus on them a lot in the future. That's it. Toodles. Oh, or you can just stop. Bye.